So welcome, everyone. Thank you so much for joining us today. This is Blockchain Fundamentals. Our speaker today is Jay McCarthy, CTO and co-founder of Reach Platform. Jay received his PhD in computer science from Brown University. Since 2008, he has been an assistant professor of computer science, first at Brigham Young University, then at Vassar College. He is now an associate professor of computer science at UMass Lowell. And I will now pass the session on to Jay.
Howdy, everyone. I'm glad to be here with you all. I am going to talk in just a moment, it'll be kind of my presentation, but before we get started there, I wanted to talk about how Reach and Algorand and Women Who Code are running a bounty hack. A bounty hack is basically a challenge to people to learn how to do blockchain programming with Reach and Algorand. And we have a variety of prizes and incentives for participating. And one of the things that's special about the bounty hacks that we run, rather than traditional hackathons, is that rather than there being a limited number of prizes that are only for the best projects that get created, instead, our goal with the bounty hack is to bring more people into the space. And so one of the things that we do is we give awards for just completing the program. So it's kind of like being paid to learn how to use these exciting new tools. And then we combine crossing the finish line with doing things like interviews and creating content about your experience, in addition to traditional prizes for, like the coolest applications or whatever. So I highly encourage you to register for the Women Who Code Bounty Hack and get involved in this. And we'll have links for that afterwards. Now, we're going to switch over to my screen. So let me just bear with me for a moment. Okay. My video should now have changed into my screen. And I want to tell you a little bit, kind of like set the stage a little bit before, going deep into the presentation, which is that, as mentioned, I'm the CTO and co-founder of Reach, as well as a professor of computer science. And today, my goal is primarily to talk to you about the basic ideas of blockchain. In some sense, this presentation would be no different than any other presentation that you would hear about blockchain, and like my status as running Reach and as being part of Algorand really doesn't have much to do with it. I'm just going to talk about blockchain generally. However, I do want to sort of have in the background that one of the main things that we're doing at Reach is we're trying to make a development platform that anybody can use to get started programming in blockchain. And so if you look at our documentation at docs.reach.sh, then you'll see this documentation site, which has ways to get started programming. And if you get involved in the bounty hack, then a big part of that will be learning the pragmatic tools and techniques to actually build on blockchain. But let's get started with blockchain fundamentals. So I think that most people, when you kind of, in my experience, when I just kind of walk around outside on the street, people have heard of blockchain. Maybe they don't really know exactly what it means. And if they've heard about it, they primarily associate blockchain with specifically cryptocurrencies. And inside of cryptocurrencies specifically, they think about Bitcoin. And so part of what my goal today is to get you to think about and expand your perspective on what blockchain is beyond just Bitcoin and cryptocurrencies. But for starters, I would like to define a little bit what the like technical thing that blockchain is, so that we can sort of have a basis for talking. And by the way, I highly welcome any questions as we're going. Please feel free to type them into the chat. And Stephanie is going to help me by monitoring that chat and asking questions as people go. Okay, so there's kind of two ways to think about what blockchain is. There's a technological way to think about it, and then the feature that it is. So by analogy, something like the steam engine, we could describe a steam engine as being, something that, oh, it like uses heat and it creates a vacuum and that moves and that converts, heat energy into mechanical energy. And so that's kind of like describing what it actually does, meaning like how it works. And the other way that we could say is that a way to describe a steam engine is that it is like a force multiplier for people's power, so that you could, and like we first use that for like transportation. So I would like to give both of these explanations for blockchain. One that is kind of the technical one, and one which is what is like the social purpose of this. Because I think it's really important to remember that like computers and like software techniques, they actually don't solve any problems. What they do is they automate existing solutions that humans have thought of independently of the program. So from that perspective, let's talk about what blockchain is technically. So basically what blockchain is a way of having a append-only data structure, where there is an agreement about the interpretation of that data structure. So let's break that down. So what do I mean by append only? Normal data structures, you can modify them over time. So for example, if I have a really simple data structure, like a number in memory, then that number in memory may be like 5 right now. And I could change it to 17, and then I could change it later to 12, and then I can change it again to 100. And so that is a really, really simple data structure. And it has the property of being read and write. You can modify it in both directions. Now, an append-only data structure would be one where it is not possible to remove information from it. So think about that number that's sitting there in memory, 17. When we change it from 17 to 20, then we have lost information about the fact that it used to be 17. But a blockchain is a data structure that is purely appending. So you can only add information to it. Now, only being able to add information is kind of a weird constraint. So before we go deeper into like why it works this way and how, I just want to point out that you can represent almost anything with this append-only information. So let's take that like counter in memory. What we could do is we could have it so that you could send the data structure would be a number, let's say, or rather a history of modifications to a number. And so you could send the operation increment the number, and it would go from 17 to 18. Or you could send the operation decrement the number, and it would go from 18 back to 17. But in fact, what the blockchain would be the history of all of the changes that happen to this data structure. And everyone would agree on what those individual operations mean. So anybody could look at the blockchain and learn or discover what the current value of the number was, even though the blockchain itself was this purely append-only data structure. Now, that's sort of like the first like technical nut of like what is blockchain. It's this append-only data structure. And there's kind of one more wrinkle, and that is that it is an example of common knowledge, meaning that everybody agrees on what the data structure is at any given point in time. Now, I think that all of us can think about situations in the world when people don't agree on what things on what things mean. But the thing that's special about blockchain is that not only is this append-only data structure, but it's paired with what's called a consensus network that helps everyone agree on what sort of the general truth about what that data structure is. Now, blockchains like this were primarily discovered for the purpose of keeping ledgers. So what are ledgers? Ledgers is just a fancy way to say a record of how much of stuff everyone owns. So every bank is running a ledger. So there's a ledger somewhere that says that Jay has $10, Gracia has $20, and Stephanie has $25. And so that data structure is a ledger. And the operations that operate on ledgers are basically transfers of funds. So Jay could transfer 5 funds to Stephanie, and Stephanie could transfer 10 funds to Gracia. And what the blockchain would be used for is for storing the current state of the ledger, or rather it stores the entire history of all the changes that have happened to that. And so this is why blockchain is associated with cryptocurrency. People were primarily interested in cryptocurrency independent of blockchain. People have been trying to produce cryptocurrency for a very, very long time prior to the invention of blockchain. The thing that was special about blockchain, it was a technique that could actually be used to produce cryptocurrency. But we are now entering a phase where we can see that blockchain can be used for so much more than just ledgers. I think we've got a question, Stephanie.
Yes, so we have a question. What chain does Reach platform support, like Ethereum, Binance, Solana, and what kind of dApps can we make on this platform?
Sure, yeah. Okay, so the question is basically, Reach is a development platform for writing decentralized applications. So what can you do with it? So right now, we support a wide variety of EVM-based chains, such as Ethereum and Conflux, and a wide number of L2s that support EVM. And we also support Algorand. Algorand is a network that has some very desirable performance characteristics relative to networks like Ethereum, and it has a totally different programming model. So when you write your program in Reach, you simultaneously get a version of your program for Ethereum and a version of your program for Algorand and all of the other chains that we support. Pretty much every decentralized application can be implemented with Reach, from small examples that are just kind of pedagogical tools to like simple games and exploratory things to full-fledged important applications. So we have people launching stable coins with Reach. We have people launching liquidity pools and all of the traditional NFT and DeFi things that people in blockchain are excited about. Me personally, I'm much more excited about people using Reach, new kinds of people entering the blockchain world using Reach for new kinds of things. So I don't think that there's an example of a program right now that people are implementing in Reach that is really exciting for me, but I think that a lot of the things that people do in other domains, they're working out well in Reach. So returning to the idea of what blockchain is, we've talked about how it's this append-only data structure that allows us to have a common knowledge about the state of something, and that this was originally used for ledgers, but it could be used for anything. And that's kind of the what does it do? What is the technical thing that it provides? And of course, there's like little details about how exactly these things work that we can talk about in a moment. But I'd like to sort of pause on that for a moment and talk about, like, why do people care about this? Why is it an interesting thing to think about blockchain? What does it really do for the world? We can kind of summarize the things that it does in 2 ways. So the first thing is that blockchain makes it so that the common knowledge part of blockchain makes it so that the cost of verifying that something happened is dramatically reduced. So there are many examples of industries and problems in the world where the main challenge is to know that somebody else really did something in a way, to know that they really did something. So for example, if you buy a house, then one of the things that you do, and part of buying a house, is you probably will buy title insurance and you will pay a title company. Now, when you buy a house, you're going to sign a big stack of paper like this big. And so this title thing is just one of them, and it's going to cost a couple $100. And what exactly are these people doing? Basically, what they're doing is they're checking to make sure that the person who is selling you this house really, in fact, owns it, that they're the ones who really own the title to that property. And they do this basically by going and checking in the court records for that particular property and making sure there's no dispute about who owns it. This is a sort of thing that would be, that's a classic example of a very high cost of verification. Someone is walking around telling you, I own this house, and it's very difficult for you to verify if they really actually do. And so blockchain basically makes it so that this is completely common knowledge, that there's this common database that everyone can go look at, this append-only data structure of, for instance, ownership. And then the question now becomes trivial. Yeah, and so that's a really simple example about what blockchain is for. Once you lower the cost of verification extremely low, you can then use that to create all sorts of other things by basically looking at industries and situations where it's hard to verify people's claims. So we see this, of course, with ledgers and cryptocurrencies because it's very hard to check how much money somebody has. They can show you, I don't know, a screenshot of their like Wells Fargo account or something like that. But for all you know, they use Photoshop and pretended otherwise. Again, a common occurrence is there are certain products where when you buy them, you can't use a normal check or a normal credit card. I'm thinking of like buying a car, for instance. Cars cost so much that typically you need a special kind of check from a bank. And this special kind of check is basically a really secure promise that this person really, in fact, has, however much money this car really costs. And so that's kind of the main problem that people were trying to solve with cryptocurrencies and why it's effective. And you can see how this purpose of lowering the cost of verification is exactly answered by the technical tool that blockchain is, this this append-only data structure. Because if something is append-only, then that means that nobody can change the past. I can always check to make sure you really do have something. And if there's common knowledge about it, then that means that no one can hide the information from you. And there's kind of another thing which I didn't quite mention is that everybody has to interpret the results the same way. And so what that means is that if the rules of the game, so to speak, are that the only person who can change the ownership of my house is me, then that means, it's not possible for Stephanie to send a message to the blockchain that says, well, in fact, I own Jay's house. And so this makes it so that there's an incentive for me to want to store my information this way. All right, so that's what blockchain is, what it provides for the world, but there's kind of this other angle about blockchain, which is simultaneously related to both of those things. And it's what we call decentralization. So I'd like to define decentralization. So something that is centralized is something where there is a single party or organization in control of resources. And this central party is the only one who can take certain actions. So for example, when we look around the world, there's a huge number of central points of control. So for example, naturally, like our governments are central organizations. Even large companies like a Facebook or a Twitter are central organizations. And even in some sense, that title agency that I talked about before is a bit of a central agency. And the value of central agencies in the normal world, when I say normal world, the world of humans touching each other and whatnot, is that when the cost of verification is very high and you can't check yourself, then essentially what we have done as humans is we've kind of organized around picking individual people where those people are the one responsible for answering this particular question, so that all the information is centralized in that party because we're nervous about there being too many different people disagreeing about certain important facts like who owns this house. And so if there are like 3 different interpretations about who owns a house, then now it can be very difficult to find out who really owns it and who you should buy for. A really interesting book about this subject in the sort of like political context is by Hernando de Soto. And he talks about how, in particular, titles are very difficult to check in some countries. Like I recall when I read this book that it talked a lot about how in Brazil, a lot of the quote favelas are kind of an outcome of the property rights, like the titles on a lot of that land being in dispute. And so people are nervous about building there, because if they build there and they don't have a clear title, then someone else might be able to take it in the future. So it's just kind of an example of how we see these central things in the real world. And of course, that centralizing party, because it's a source of trust between two people who otherwise can't verify each other's claims. That trust leads the person in the middle, that central party, to basically be able to extract rents, which is like an economic term for make things cost more. If something would have cost $1, but when you go through the central party, it costs, $1.10, then that means that that 10 is a rent that they're collecting by providing this centralizing service. So they make things more expensive, and they also can exert like control and censorship, for instance, on whatever the central thing that they're arbitrating on. So, for example, I think that we're all familiar with Twitter and Facebook controlling access to certain information and to implement whatever their policies are. Whether you think that they're good policies or bad, they clearly are in fact doing this. So that's what centralization is. So blockchain, by lowering the cost of verification, what it does is it makes it so that people can get the same quality of information, but not use these central parties. Therefore, there's this trend of decentralization that is created by the technology of blockchain, because people don't need to go through those central parties to get the information that they need. I saw a question in the chat, so let me just pop over to that real fast. So someone asks, can Web 3.0 overtake Web 2.0 in the recent future? Can blockchain fulfill all short of requirements which are served by Web 2.0? So I just want to interpret this question. So we generally refer to the blockchain economy, the blockchain world, as Web 3.0. The idea being that Web 1.0 was the time when websites were primarily created only by companies, and that they did not like basically tap the resources of individuals to create like content and control. And then Web 2.0 is when we have more active participatory websites. So these are things like, a Facebook, a Reddit, etc., a YouTube. And Web 3.0 is this vision of what we can produce with blockchain. And so the dream, of course, is that Web 3.0 can supplant Web 2.0. And so the question is, can this in fact happen? And can we do it for all? Can we use Web 3.0 for everything that we can do for Web 2.0? As someone who is running a blockchain-based company, you might think that I would say, oh, of course, it can do everything. But the thing is that Web 2.0 has some very valuable, it offers very valuable things. And Web 3.0, i.e. blockchain, adds some features, but some of them come at a cost. So for example, while blockchain makes it so that the cost of verification is very inexpensive, it doesn't make it free. And there are some things where we don't want to pay for them. So I'm going to speculate for a moment. Right now, you watch things on YouTube or you watch things on Twitter, and it's very easy for you to click the like button, because when you click the like button, you're signifying your approval of whatever the thing that you looked at was. You kind of know that when you click that like button, it will influence the algorithm to determine what you're going to look at next. And you also kind of know that it kind of helps the creator that you're pressing the like button on. But imagine that you had to pay money every time you click the like button. Of course, you kind of do have to pay money because you're paying for your electricity and your phone bill and whatnot, but you don't really think of it as you're paying for that click while you are. If you thought about, I had to pay every single time I clicked one of these things, you might not do it. And the way that blockchain works today, it's not possible to do any action without it being added to this append-only record of everything that ever happened. And because blockchain right now is so nascent and expensive, it's relatively expensive to do that because we don't have a variety of different blockchains for different purposes. This is the world according to Jay. This is my opinion. And so I think that it's unlikely that if we were to transparently recreate the Web 2 world in the Web 3 world, like with the Web 3 technology, using all of the same ideas, I don't think that people would be willing to pay to click the like button. And that's the way that it would work on blockchain. And so that really basic analysis tells me that there's always going to be a place for many, many Web 2 programs and practices and applications and whatnot. But Web3 does have this very powerful tool in its pocket, which is that it lowers the cost of verification, and that leads the way to lowering transaction costs and removing power from central parties. So when we look at the Web 2 world and we see those things cropping up, verification being expensive, transaction costs being too high, people exploiting their position of power, those are all very powerful avenues for doing Web3 transitions. So as I was saying, the goal of blockchain, or rather a thing that blockchain can do, is that it can produce this decentralizing trend. And we see in blockchain design a variety of ways in which we do that by people, for example. If I were creating a Web 2 startup, let's say, if I told you, oh, I'm starting a Web 2 startup, then everyone would say, oh, okay, that means that you're going to create this website and you're going to have like a secret code repository that's going to control the software on that website. And people are going to go to the website and they're going to use it, and you're going to do something for them, and you're probably going to collect their data. And when you collect their data, you're going to, sell it to advertisers, but you're also going to try to use that to do a better job for them. Like what I just described is sort of like the Web 2.0 company in a box. Like that pretty much describes almost all of them. And it's very typical when people are thinking about the design of a Web 3 application, is to think about it differently. They think, okay, well, what I'm going to do is I'm going to design a protocol that determines how two people talk to each other. And then I'm going to provide the software that will make it so that Jay can talk to Stephanie using let's just pick a random thing. Let's say that, I don't know, we're talking about the blockchain version of Uber, right? Right now, Uber is an application you run on your phone, and it's a server that is out there in the cloud somewhere. And the phone is software that you don't control, and the server is software you don't control. If we were to imagine the blockchain version of Uber, probably what we would imagine is that there is just a software protocol where anybody can run a Uber client. And I would say I'm the client. I would use my Uber client and create an Uber contract. And Stephanie, she's a driver, let's say, she's going to run her Uber driver searching program that's going to look through the blockchain and find everybody that's interested and find one that's close to her, that fits the characteristics that she likes, about the kinds of customers that she wants to have. And then she's going to bid on my contract. And when she bids, maybe she'll win, and then we'll be connected to one another. So this idea of creating an open protocol that anybody can use to carry out whatever their goal is, this is the standard design practice of blockchain. And it is an example of this decentralization, where the idea of decentralization is to make it so that we use blockchain to create an ecosystem where there are no central parties at all. There's another notion of decentralization that I want to mention just before we finish this topic, which is that inside of the implementation of blockchains, they often use decentralization themselves. Because remember, one of the things I talked about is that we have this append-only source of information of the data structure, but we also have a consensual view of it where everyone agrees on what happened. Well, it's difficult to achieve a consensus view about something without giving power to a central party. And so baked into pretty much all of the blockchain designs are ways to make it so that the consensus making mechanism is widely distributed to thousands and thousands of people, where they all are running one of these example protocols to determine what the truth is at any given moment. And I'm sure you've heard of, for instance, the way that the Bitcoin uses this mining system. And the idea of the mining system is that everyone agrees to follow certain rules about producing the next block. And producing the next block is computationally intensive, and running that process is what we call mining. And so this is the kind of decentralization that happens inside of typical consensus networks. But you can use that decentralized consensus network to actually create something that is itself centralized, that runs on top of the blockchain as a single source. So for example, using the Uber analogy, we could imagine that open protocol version of Uber, but we could also imagine a version of Uber that was like a single program on the blockchain that was managing everything. And that would be like a centralized blockchain program that was running on this decentralized network. And so one of the things that you'll see when you start studying blockchain is that there are a variety of these different designs. There are centralized smart contracts, and there are decentralized ones as well, and they're not all the same. Okay, so I now want to use that kind of guise to go back to the original thing that most people think about when they think about blockchain, and see how it relates. So that is crypto, meaning cryptocurrencies. So of course, one of the underlying technologies that is used to implement blockchain are cryptography. And what cryptography does, essentially, like, we normally think of cryptography as allowing us to do things secretly. But the secrecy aspect of blockchain is not really relevant. The secrecy aspect of cryptography in blockchain is not really relevant. The thing that matters more is the authenticity. So one of the goals of cryptography is to make it so that I can say something and you all know that it was me who said it and not somebody else, not somebody pretending to be Jay. And so the reason that this is important is that a typical core feature of blockchain designs is that there are resources that can only be controlled by a particular party. So that is, it's my taxi contract, it's my house, it's my, it's my funds in my wallet. Each one of those things is something that is associated with a particular person. And since they are associated with a particular person, we want to ensure that whenever that person wants to act, we know that the request to act is coming from them. So typically the part of cryptography that matters are what's called signatures, rather than the sort of the secret part of them. Okay, but now when people say crypto, they typically are talking about cryptocurrencies, which is a particular use of blockchain to provide the ledger data structure. The ledger data structure being the one that just says how much money is in each one of our accounts. And the main transaction, the main change to the data structure that happens is transferring of funds. So, Jay can pay Stephanie. And let's kind of think about this from the perspective of, decentralization and about what blockchain provides. What's being provided is basically the ability to verify that someone really has the funds that they said that they do, to verify that they really did pay you and they can't take it back. And then to make it so that anybody can make these two things independently of anybody else. So that's, you can check how much money I have, you can verify that I really paid you, and we can do both of these things without asking anybody else for permission. In the normal world, you don't have this capability. And I think this is something that's really surprising for people when you, because they've never really thought about it before. So how can you prove to somebody else that you really have funds in your account? As I said, you could take a screenshot of your bank account page, but someone could be lying to you. You could walk down to the bank with somebody else and say, hey, check it out. Like, look, this guy's telling you, okay, but that's the centralized party. That's the other person being the one. I can't prove independently of anybody else that I have these funds. You'd have to, look at my account. We can do this with actual physical dollar bills or gold or something like that. But even with those, there's kind of this suspicion that maybe that's not a real dollar bill, maybe that's not really gold, etc. Now, similarly, it's typically not possible to trade with somebody else as well, because when I pay someone with physical dollars or gold, yes, I can hand it over to them, but as I said, they're suspicious. Maybe it's not really the right kind of thing. But when I give somebody funds using my bank account, basically I'm instructing an agent, the bank, to send the money to them. And this can typically happen very fast if we both happen to use the same bank. So if you use Wells Fargo and I use Wells Fargo, then the transfer can happen pretty much instantaneously. But if it just goes behind two banks, then it will typically take like 5 days almost for the transaction to settle, which means that it has left one person's account and it really has been considered to arrive in another's. And we have to use a central party, the two banks. And in fact, there's kind of a third party that we don't really think about, which is the clearinghouse, in between them, to make sure that it actually happens. And all those people in between you and me who want to trade money with one another, they basically get in the way of making this trade happen fast and efficiently. So we can see how the main things that blockchain provides were so useful in cryptocurrency. And we see that in currencies in general, there are these sort of natural problems sitting on the sidewalk that we're just waiting for people to solve. So that's why cryptocurrency has been so associated with blockchain. And if I can leave the facts for a moment and talk about the theory of the world according to Jay, whenever we discover something new, it gets applied to things that are the most expensive, highest yield domains that it could be used for. So for example, when we invented steam engines, we used them for mining. We didn't use them for creating standing desks. I have a standing desk right now, and it uses electricity to move it up and down. It doesn't use a crank. And it would be possible to make a steam engine version of a standing desk in the 1820s, but nobody did that. And the reason nobody did that is because it would take a lot of work and there would be very little reward for doing it. Instead, we used steam engines for the thing that was the most pressing, most expensive issue of the day, which was mining, and then moving things by freight, which is why we created trains. We see the same thing in the history of other problems like, I don't know, like computers, for instance. Computers were originally made primarily for doing artillery predictions. So we have a new artillery piece and we'd like to know whether or not what angle it should be pointed at to land over there. And so computers were primarily made to produce artillery tables, which were, highly computationally expensive things that were really important for the quote bottom line of the military who invented them. So that's kind of an example of how things get used for their highest yield, or at least what's considered highest yield by their creators. And so when we look at the blockchain world today, I think it is a mistake to think that the defining thing about it is cryptocurrency and decentralized finance and things like that, because what we're really observing is that these are things that have the highest margins today, where if you use cryptocurrency, you're taking something that used to take 5 days to clear, and even in a geriatric network like like Bitcoin, you're reducing that 5 days to on the order of 30 minutes, you know what I mean? Which 30 minutes sounds like a lot, but it's not a lot when you think about the alternative being 5 days. And when you're talking about a network like Algorand, you're taking that 5 days and turning it into 4.5 seconds. So there's this huge gap between the service that is currently existing and what blockchain can provide. And so that's why we see it being applied there right away. But our mission at Reach is to bring all of you and thousands of other people into blockchain to discover new uses that are not just decentralized finance. Right. So given that blockchain was originally used for cryptocurrency to just create the currency period, I think it would be useful to talk a little bit about how it is currently used today. There's not really a what you might call a killer app, which is something that would, I don't know, motivate my mother-in-law or my nieces and nephews to care about blockchain. So we can't point to something like like a TikTok or something like that, like something that is like a casual person can understand why the internet and the smartphone was really valuable for producing this thing. Nevertheless, blockchain is being used. And I would say that the two primary things that it's being used for, the most popular uses today, are what's called DeFi, or decentralized finance. And the other one are NFTs, or non-fungible tokens. Let me talk about both of these in turn. So decentralized finance is basically a way, is what we use to refer to creating, quote, sophisticated financial products using cryptocurrency and about cryptocurrency. So as a really simple example, last summer, I think it was last summer, it was very popular. There was this trend to trade GameStop stock. And the thing that was special about that is that people noticed that there was a company who was doing a short on GameStop. And basically what a short means is that they think that the price will go down in the future. And so if today I borrow, or rather I buy from you your GameStop share for let's say for $10, and then what I do is I promise to return it for $10, but I think that it will go down in price to $5, then I can take the $10 today, sell it, get $10, wait until I'm supposed to give it to you, buy it for $5, and then return your share back to you and pocket the difference, which is $5. So that is a really, really simple way of thinking about what a short is. And a short is an example of one of these, quote, sophisticated financial products. So people normally just buy and sell normal things like the actual, Lego or the actual GameStop share or something like that. And what people have done in the finance world is invent more and more complicated products because not just for fun, but also because, as a way of basically hedging risks. So we're all familiar with insurance. The idea of insurance is that you pay something now so that in the future, if something bad happens, you don't hurt as bad. And so pretty much all financial products can be seen under the guise of they're insuring against some sort of risk. So for instance, what does a short insure you against? It makes it so that if the price of the thing goes down, then you make money. So who might want to buy that? Well, in fact, people who their livelihood depends on GameStop might like to buy this, because if GameStop is successful, then GameStop will pay them because they work there, for instance. And if it's unsuccessful, then they'll get the same amount of money by exercising their short. And so that's kind of a really, really simple way of thinking about how shorts and many other financial products basically are kind of complicated insurance policies. Okay, so what we see in the blockchain world today is that a lot of these complicated financial products are being ported to blockchain because there's money there. And if you can use that money to do something, well, then you can use it to do these complicated things. And in particular, because the trading velocity is so much faster on blockchain because we don't have that 5 days, we have the 4.5 seconds on Algorand, for instance. And so that makes it so you can just make decisions and make trades much, much more quickly. And so that's one of the reasons why we see decentralized finance being a really prominent thing right now, because it's kind of a great use case. Okay. Someone asked the question, which particular sector mostly influenced by blockchain technology? Can traditional finance sectors like banks be replaced by DeFi in the future? So this is kind of what I'm talking about right now, which is that right now, almost no industry is impacted by blockchain. We are in the nascent time when we believe that it will be influenced by them. But if anything is being influenced the most, I would say that it's definitely finance. And that's because there's so many great returns to having the really fast settlement that blockchain provides. Now, can they be replaced? I don't have a crystal ball over here. I can tell you, I'll give you an argument for why they will be replaced, and an argument why they won't be replaced. An argument why they will be replaced is that 4 seconds is better than 5. days. And so because that means that the product will be better on blockchain. And since the product will be better, people will push to use it. And the world will get better because things will be more efficient and they won't have to wait so long. My parents, they, for instance, recently bought a new car, and they needed to make sure, it took them almost like 2 months to transfer all the funds from one bank account to another so they could get a registered check, because they didn't want to pay the big fee of doing a bank transfer. So they figured out how they could, slowly transfer the money. And this is kind of a problem that would be totally removed if their bank accounts were just on blockchain. Not to mention that they wouldn't even need the registered check in the first place, so they could use their normal bank. Now, an argument for why it won't be replaced is that the financial sector is heavily regulated, and many people believe that it's regulated for a good reason. And nevertheless, it in fact is regulated, and regulations change extremely slowly. And many of the things that are very valuable that the finance industry does are mandated by law to work the way that they work. So that means that this is not a domain that business people and technologists can just independently innovate. They have to innovate after getting permission, and it takes a long time to get permission. One of the things that Machiavelli says in The Prince is that whenever you intend to make a change to the world, you're going to be fought by the people who will lose their benefit after your change, but you're not going to be able to be allied with the small number of people or the diffuse people who will benefit from your change. So since the core thing that blockchain does is it lowers the cost of verification, which makes it so that we don't need to have these central parties that can extract rents. Well, those people, they don't want to give up their rents. And so they're going to do their best to prevent the creation of blockchain-based industries. So that's my argument for and argument against. Now, I'm going to say that there's this other nascent use of blockchain, which are called NFTs. So NFT literally stands for non-fungible token, but I don't think it's valuable to go into the details of why it's called that. What NFTs are is they're a proof of ownership of something. Many people, again, if you were to say, oh, what's an NFT? They would say, oh, it's a weird picture that people are spending hundreds of thousands of dollars on. It's not really that either. The NFT is that idea that I talked about at the beginning of verifying who owns the house. It is the title insurance problem, which is that there are some things out there that we are concerned about who really owns them. And NFTs are a really simple way of making it so that the ownership of an asset, either a digital one or one in the real world, is represented on the blockchain in a way that anyone can verify who owns it. I can transfer or sell it without anyone else getting involved. And I don't need anybody's permission to show that I own it, to give it to somebody else or anything like that. And people right now are applying the NFT idea with these pictures, that I'm sure you've seen. And the pictures there, sometimes the thing that's important is who owns that particular picture, that particular picture is interesting. But oftentimes, the NFTs are really a veil for basically membership in like a club, let's say. So it's one thing to say that you are a fan of, I don't know, Cyndi Lauper. Okay, so I'm a fan of Cyndi Lauper, and it's very cheap for me to say I'm a fan of Cyndi Lauper. But if I want to go hang out with true fans of Cyndi Lauper, I have to perform an expensive signal. So for instance, this is why my friends, when I was a kid, there were the kids who said that they liked punk rock music, and then there are the kids who gave themselves mohawks. So it's very expensive to give yourself a mohawk because now everyone is going to look at you funny. But if you give yourself a mohawk, you must really like punk rock music. And so that is a way to prove your membership in a club. And so the NFTs today, they are very expensive signals for wanting to be part of a club. And that produces, club loyalty. People are like, oh, you really are in this club because you spent all this money to get inside of my club. And so, humans really love being in clubs. They really love finding people with similar goals, similar desires, similar vision of the world. And we're seeing that occur on using blockchain as a tool where people can show that they're a part of a club in a way that other people can't fake. Because, it's one thing to shave your head and give yourself a mohawk, and it's another thing to just, spike your hair on the weekend. You know what I mean? You can pretend to be punk rock for just 1 week, but, shaving your head is serious. So people are very concerned about, I don't know, having fake versions of things. So there's the person with the real Prada bag and the person with the fake Prada bag. And the person with the real one wants to be able to out the person with the fake one. And so NFTs are a really interesting social phenomenon where club and community membership are an example where the price of verification can be very high in some cases, especially if we're talking about people across the planet. It's very difficult for me to verify that you're a member of my tribe when you're thousands of miles away, but NFTs provide a way of drastically lowering the cost of that. So we are in fact seeing blockchain being used both for decentralized finance and for NFTs. And I think that those two things are really interesting, actually, because they're almost completely diametrically opposed to one another. Whereas the DeFi space is primarily about like finance and money, and the NFT space is primarily about community and belonging. And I think that it's really interesting and powerful that blockchain is being used so effectively for both of these things. And I think that over time, we will see the blockchain world fill in with even more and more applications. I think that as we've been going, I've talked about some of the pros and cons of blockchain, especially when I talked about how everything on blockchain right now costs something. And there are different networks with different profiles of cost. And as blockchain evolves, we will see more and more specialized blockchains that have different pros and cons. I'm kind of speeding up now at the end because I talked a lot about the beginning stuff. So I talked at the very beginning about like what Reach is, right? Reach is a blockchain development platform that makes it easy for people to get into blockchain. So all of the detailed stuff that I talked about, oh, it's this append-only data structure. It's like when you use a development platform like Reach, you don't really need to know about any of those things. It's useful to have a bit of a perspective about what dApps are providing, but none of the underlying technology is something that you need to think about. Just like when you design a web app today, you don't need to know anything about TCP/IP or about how messages are split into packets and what exactly is the the minimum length or the maximum length of an Ethernet cable. All of these like low-level details are totally irrelevant to you when you're building something that solves and helps humans solve their own problems. And so the goal of a blockchain development platform is to insulate you from those low-level details so you can focus on the true value of blockchain. There are a wide variety of blockchains. I've talked about two of them today. I've talked about Ethereum. Well, I guess I talked about Bitcoin, Ethereum, and I talked about Algorand. And there are a wide variety of them. And many people who are trying to get you into blockchain, they're going to obsess about particular chains. And I want to explain a little bit about why they're obsessing with them. They're primarily obsessing about them, and maybe this is a little bit mean of me to say this, but they're primarily obsessing about a particular one because they have a lot of money invested in that one, and if you use it, then their money will be more valuable. The other reason, though, maybe a less mean reason, is that they have very different performance and technical characteristics. And if you are a technologist, it can be really exciting to talk about and care about those things. But my perspective on this, and the perspective that we take at Reach, is that when you use a website, you don't think to yourself, wow, I can't wait to use that site that's using MongoDB. And your friend over here is saying, no, I want to use a website that uses MariaDB. We don't really care about what the underlying technology of products is. We care about what they do for us. And so similarly, our goal at Reach is to make it so that not only can consumers focus on what blockchain does for them, but developers can focus on what blockchain does for them as well, rather than pushing themselves into the mold that existing blockchains force you to do. So this is the reason why Reach is a blockchain agnostic development platform. So you can develop your application in one mechanism, and then you can target it to different blockchains over time based on what your taste or needs are. I've talked throughout the whole time about Reach, And I just want to kind of end with one big idea about Reach. Right now, there are optimistically 30 or 40,000 blockchain programmers out there in the world. And blockchain will never be a transformative social phenomenon unless there are millions of developers. And so the point of Reach existing is to enable tens of thousands, hundreds of thousands, millions of people to get involved in blockchain and find ways that a problem that they care about can be improved by having lower costs of verification, by having more decentralization, and less central control by powerful parties with vested interests. And this is the explicit goal of Reach. And that's why I wanted to talk about those things as your introduction to Reach, not about like, oh, here's how you program this particular thing. Because honestly, though you are really smart and you can learn those things relatively fast, but I feel that the more important thing is to help influence people so that they can understand why they would want to get involved in blockchain at all. It's not just about cryptocurrencies or decentralized finance. It's much, much more important than those things. All right. So this April, we're starting the Women Who Code Bounty Hack. It's a partnership between Women Who Code, the Algorand Foundation, and Reach. And I'm really excited to have you all part of it. I'm happy to close up with any questions, and we'll see you there at the Bounty Hack, I hope. Thank you so much for your time.
Thank you so much, Jay. We do have a question that just came in the chat, which is a fantastic question. How can a beginner participate in Bounty Hack?
Yeah, so the goal of Bounty Hacks is for everyone to be complete beginners. You do not have to be an expert to participate in the Bounty Hack. What we do in the Bounty Hack program is it's a multi-week program. I think they're all 6 weeks. Where in the beginning, we basically incentivize you to go through the training materials that we have on Reach. And those are designed for someone who has no blockchain experience whatsoever, who just has experience, moderate experience with programming and in the Web 2 world. And then from there, we help you form a team and choose your own project to work on, and then get started building that project. In one of our first Bounty Hacks, we had one of the winners, actually. I think they came in second place. They were an 11-year-old kid who was doing it as a homeschool project. We've had people from all over the world, all walks of life, all backgrounds in programming participate in these Bounty Hacks, and you absolutely can do it. You don't need to have any prior experience.
Fantastic. Another question. Can we participate if we are front-end developers?
Yeah, so one of our goals with Reach is, as I said, make it so that anyone can participate in blockchain. And so I'm going to interpret your question in 2 ways. So first, I'm going to say, oh, I'm a front-end developer. I can't do this crazy backend stuff. You can do the crazy backend stuff. So if you want to, you can. But on the other hand, I do want to point out that in my experience, when people don't use a platform like Reach, the blockchain part of their work consumes like 80% of their time. And that means that they perceive working in blockchain as being primarily about smart contracts, cryptocurrency, running this, all of these complicated things. But when people use Reach, it's often the case that the blockchain portion of their work will be done extremely quickly. And then almost all of their other time will be spent making a great application using their front-end design skills. So for example, just yesterday, people associated with Reach launched a product called Humble Swap. And they've been working on that for 3 to 4 months. And almost all of that is on the design front-end side. So if you're building a real program, then that means that you need to work with real users. And that means front-end programming, not this, weird cryptography backend stuff. That is a totally important and valuable skill in the blockchain world. And there are things to learn as well, because there are different paradigms about how the program will work and how to communicate with your users what it does. So it won't be boring either. You'll learn new things.
Wonderful, thank you. Another question, is this going to be on April 11th and what time?
Yes, it starts on April 11th, and I do not know exactly the details, but when you register, you will be put on the mailing to be told about, okay, it'll work exactly this way. We'll do a webinar at this time to introduce you. Estefania Ochoa, who works at Reach, is the main organizer of these, and she'll, take care of you really well.
Another question, are the training materials paid or free?
Everything is free. Yep. So, and actually everything is available online right now. So if you go to docs.reach.sh, then you can get started.
Another question, to form the teams, are you going to take into account the time zone and this person is located in Ecuador?
Yeah, we have been doing, so that's something that we facilitate people forming their own teams. And we try to do exactly the kind of thing that you're talking about. Make sure that people are in similar time zones, want to speak similar languages, etc. And we have many people in Central America already.
Fantastic. Well, thank you everyone so much for your questions. I think that's all we have for today. So Jay, thank you so much for joining us today and sharing this amazing knowledge. And I'm very excited about the bounty hack, and I definitely encourage everyone to participate and, definitely give it a try, go for it. And it should be an amazing experience. And it really is an amazing program. So thank you, Jay, so much for joining us today.
Definitely. Thank you all for having me. Have a great day. See you in 2 weeks.